These are the frequently asked questions for pre-calculus for section 2-1, day 2. And starting with number 27, we have find the vertex and axis of the graph of the function. Rewrite the equation for the function in vertex form. F of x equals 3x squared plus 5x minus 4. So we'd use the completing the square process to get this taken care of. Switch this to a y. Recognize that completing the square only works when your a value is 1, so we'll have to divide both sides by 3. Y over 3 equals x squared plus 5/3 x minus 4/3. And pretty obviously the negative 4/3 is not a perfect square, so we will add that to both sides and have x squared plus 5/3 x. And again, just to keep things, well, from getting too complicated, we do have a common denominator over on this side, so we might as well write that as y plus 4 over 3. And on the other side, this is where we want to focus our energy on the value that will complete the square. So we have 5/3. We need to divide that by 2 and square it. But when we divide a fraction by 2, we're really multiplying by the reciprocal, which would be 1/2. And then we'll square that. So when we multiply that by 1/2, remember it's just with fractions, if you can't cross reduce, it's just top times top and bottom times bottom. So that will really be 5/6 squared, which is going to be 25 over 36. And let me move this up because given that we're working with so many fractions here, I'm probably going to need some more space to show you what we need to do here. So we need to add 25, 36 to both sides. Now again, on the left-hand side, it would be nice if we could go ahead and put these things together. So I see that my denominator is now going to be 36, and I recognize this entire fraction will need to be multiplied by 12 on the top and the bottom. So that will give me 12y plus 48 over 36 plus 25 over 36 equals, and I now have my perfect square accomplished on this side. Because when I did my b over 2, I had 5/6 that was squared. And because everything on this side is going to be using addition, that'll be x plus 5/6 squared. So now let's put together what we have on the left side here, which is really just figuring out, because the 12y is not a like term, we really just need to figure out what 48 plus 25 is, and that's 73. So now this is going to be a lot nicer to move everything back because we did all the math on the left-hand side to make that happen. And I want to make sure that looks like a 6. All right, so next up would be multiplying both sides by 36. Again, we're not going to distribute it or anything. That's going to be our a value right there. And then we would go ahead and subtract 73 from both sides. And then we would divide everything by 12. And again, you have to think of this as two terms. Remember, terms are things that are separated by addition. So these are two terms, and each of those terms gets divided by 12. The reason that I wrote it underneath the 36 is because obviously that's what I want to cancel it with on the other side. All right, so that is a good one. And now what we want to do is go ahead and recognize the pieces that they asked us to recognize. So in that group of problems, it said, find the vertex and the axis of the graph of the function. Rewrite it in vertex form. We have it in vertex form. So our vertex, remember this is x minus h, is going to be negative 5/6, and then k is in the back, negative 73/12. And then our axis of symmetry is always going to be through the x-coordinate, vertical line through that x-coordinate, which of course was a negative 5, 6. So we have our vertex at negative 5, 6, negative 73/12, and our axis of symmetry at negative 5, 6, and we have it in vertex form. It's beautiful. Really nice problem. Quite a few fraction pieces to keep track of there. And as I'm scrolling down, you can see that problem is a lot of work. And as we've talked about, one of the things that we really needed to do in pre-calculus is beef up your algebra skills. And this is definitely a problem that will beef up your algebra skills. All right, next one that you had on your list was number 28. And again, I'm just going to make that f of x piece the y. And recognize that this negative 2 cannot be here, so we need to divide everything on both sides by negative 2. So y over negative 2 equals x squared minus 7/2 x plus 3/2. We recognize that 3/2 is not a perfect square, so let's subtract that from both sides. All right, so now the fun begins. On the left-hand side, we talked about this the other day, that negative does not necessarily have to be on the bottom of the fraction. It just needs to be there, whether or not it's on the top, or it's on the bottom, or it's out in front of the entire fraction. That one negative takes care of that being negative. So we do have a common denominator, and we can just make this negative y minus 3 over 2. And on the other side, we of course are going to be looking for that c value that will complete the square. So we have negative 7/2 divided by 2 squared, but as I talked about in the last problem, really what we're going to do when we have the fractions is we're going to multiply by the reciprocal, which will be 1/2. There is no cross reducing that we can do on this problem, so top times top, bottom times bottom gives us negative 7/4. And if we square that, we get 49/16. So we will need to add 49/16 to both sides. Now, up next is getting that left-hand side to be a little easier to work with, so this isn't difficult to do later on. I have a denominator of 16 and a denominator of 2. If I multiply everything in this first fraction by 8, then I can get that common denominator. So negative 8y minus 24 over 16 plus 49 over 16. And on this side, we know that we've already achieved that perfect square, trinomial. So what we squared to get our 49/16 was a negative 7/4. Oops, negative 7/4 squared. And on the other side, we need to figure out what 49 minus 24 is, because negative 24 plus 49 is the same thing as 49 minus 24. And of course, that's 25. So negative 8y plus 25 over 16 equals x minus 7/4 squared. All right, well, let's move everything back. We have 16, so we're going to multiply both sides by 16. And that will give us negative 8y plus 25 equals 16 times x minus 7/4 squared. And then we would go ahead and subtract 25 from both sides. So 16 times x minus 7/4 squared minus 25. And then divide everything by negative 8. Remember, it's all the terms that are being divided by 8. And we have 2 terms over here. Terms are separated by addition. So we'll have y equals, well, 16 divided by negative 8 is negative 2 times x minus 7/4 squared plus 25/8. And that, of course, is in vertex form. I was just thinking about the last one. I really should finish it up by making that f of x again as it was, because it is the same function. It's just written in a different form. And then our vertex, x minus h, so our h value is 7/4, and then k in the back, 25/8. Axis of symmetry, x equals, remember vertical line, that's going to cut through the x-axis at the vertex, which would be the 7/4. So there is the vertex form, the vertex, and the axis of symmetry. Another really good problem algebra-wise. I'll have to keep track of there. And then the next one you had asked for was 36. And this one flat out says, use the completing the square to describe the graph of each function and support your answers graphically. So 36, y equals 8 plus 2x minus x squared. So let's reorder this. And that negative in front of the x squared has to go. It absolutely has to. It has to be a positive 1 in front of our x squared term. All right, so next up is recognizing that that 8 in back is not a perfect square and adding that to both sides. The b over 2 squared, so negative 2 divided by 2 squared is negative 1 squared, which is 1. So we need to add 1 to both sides. Left-hand side will be negative y plus 9, and the right-hand side is now that perfect square of x minus 1 squared. Again, we just check right here. Our b over 2 is the value that we need to put in this position. And now let's move things back. So we're going to go ahead and subtract 9 from both sides. And divide by negative 1. Again, there are 2 terms here, and we have to make sure that both of them are divided by negative 1. So on the left-hand side, we'll now have y, but we'll have a negative x minus 1 squared because that was the first term, and a negative in the back will give us a plus 9. And let's check out what the name of this one was originally. 36 was originally h of x. So we'll put that name back on there. And then we'll check out everything else that they wanted from the directions. It says, use the completing the square method to describe the graph of each function and support your answers graphically. Well, that would mean we want to know where the vertex is. And our vertex is hk. So that means that our h value is 1 and our k value is 9. And our axis of symmetry is at x equals 1. And then we certainly could, find a few points that are on this. I know the book went ahead and gave you the x-intercepts. So you could always graph it and then from there see what you have. So the x-intercepts are at x equals negative 2. So I'll just write that as the ordered pair. Negative 2, 0. And 4, 0. Up is number 53. It says table 2.6 shows the average hourly compensation of U.S. production workers for several years. Let X be the number of years since 1970. That's important because that tells us we're supposed to put 5 in for 1975, and then it'll be 15 for 1985, and 25 and 35 for those next sets of numbers. And then we have the hourly compensation over there. And A says, find the linear regression model for the data. So I went ahead and put the data into my calculator. And now what I want it to do is, of course, linear regression. So stats calculate number 4. And I have list 1 and list 2 in there already. But I'm going to go ahead and do variables. Arrow to the right once for y variables, number 1, so that I can have that saved in my y equals. So there's my regression, and that's the first part of this answer, of course, is just getting that far. So find the linear regression model. Y equals, well, something didn't like where it was located there. There we go. Y equals 0.371x plus 2.891. There's our linear regression model for the data. And it says, what does the slope in the regression model represent? Well, what we're finding is the change in hourly compensation per year, because we put those in as fives. So for part A, we'd finish it up by saying the change in hourly compensation per year is what we're truly finding with that 0.371. Because it's money, we might want to go ahead and say it is approximately and that does not look like approximately. This scrolled up a little bit so you can read this easier. The change in the hourly compensation, and it is approximately 37 cents a year. So that's all for A. B says use the linear regression model to predict the production worker average hourly compensation in the year 2015. Well, 2015 would be 45 years later. So X equaling 45, because remember all of this started in 1970. So maybe we'll go ahead and use that ask feature, and that is second table set. And go down to ask, second table, and we want to put in a 45. And it shows us that it will be $19.59. And we could have just started our table at 45 as well, you know, change the table startup right there. But that is our prediction.